Okay, guys, I know that the recitation is due on Friday, so I know that a lot of you want to get working as soon as possible. So I just want to go over this and show you kind of what the status is here. It is it's basically frozen at this point. So this again is the basic schema here. We have jobs and work orders. Okay, so these are like assignments of workers to like actually work on the job. And then we have the customer, and there's only one customer per job. Okay, and then finally we have a sales rep. But you guys are the ones who are going to put the sales rep in. That goes later. Okay, so to make this more concrete, the types of jobs here are these painting and roofing jobs, and they transition every day. They have a probability of transition on this Markov network. So it goes from like they all start in quoting, and then 10% of the time that'll transition to painting. But sometimes 10% of the time it'll also translate to loss. And then things kind of go around here. So there can be disputes. So even as you're painting, disputes can arise with a pretty low probability. And then disputes can either wind up in a lost job or none, or going back just to doing the work. Okay, but in any case, anytime you enter the painting here or you enter the roofing, because there's a corresponding Markov for the roofing jobs, anytime you enter here, it does the job, the work order scheduling. Okay, so that's all inside the code. So maybe what we should do here now is let's go and let's look at the code a little bit before I get to the questions that you guys have to figure out down here. Okay, so let me just do a quick code review. Okay, so when you download that zip and you unzip it, you're going to basically wind up with something like this. Now, I'm assuming you guys are all going to be able to get this Psycho PG2 through pip. So I'm assuming that there's a certain amount of Python understanding here. We can talk about it tomorrow if there's any problems with just getting the installation to work. Anyways, this is just some quick Python that runs the simulator. So we have the number of days. We're going to run 80 days of simulation. And then the number of jobs that are coming in, which half are going to be painting, half are going to be roofing, is going to be on the order of a uniform distribution between 0 and 30. And those are prospects, of course. So they're all just entering the stages, the initial stages, which in the case of painting is quoting, and in the case of roofing is estimating. These are the first names and the last names. So these are just like some stuff we build the names with. Here are our cities in Sweden here, and the database name is roof. Okay, and then what we do here is this is just generating all the customers randomly, and this is generating the workers randomly. And the simulation is very easy. It just takes the current date, and this is starting in January 1st, 2024, and it's going to be going through the 80 days, I believe, is what it was. Yeah, 80 days. It's going to go through 80 days, and it's just going to basically go here, and it's going to insert a job here. And this job, of course, is going to the triggers and the active database components. We'll see in a second. Put these jobs into the initial stage. All right. Yeah. And then right here is just another thing right here where we update the current date in the data model. And this, of course, also triggers additional stuff. So let's look at the active components here. But maybe before that, we'll just look at the initial database. So here's the initial database that just gets built. Customers, workers, jobs. This is essentially the set of the basic tables that were already in that ERD from before. This, of course, is what encodes the transitions of the Markov network. And yeah, so this should be fairly straightforward here. So now this is where like the core of the approach is. So these are the active components in here. So every time you insert a job here, what it does, so here's the trigger. So on job. So after the insert of the job, which is coming from that Python code. What it's going to do is it's going to execute this PostgreSQL, PLPGSQL code insert job, which is right here. So what it does basically, this is returning a trigger. So the triggers, the way they integrate it, I think we went over this a little bit before. This just happens to be how you define triggers in this procedural language. They're kind of linked together. So this is returning a trigger, and that's going to be what's when it executes the procedure here, it wants that as a returning a triggers because it's being done in the context of a trigger. Okay, so anyways, updates the job, and what it does here is it just simply goes to the initial stage table, and we'll set based on the type, if it's a painting or a roofing job, it'll set the type properly. Okay, fine. So that happens. That kicks that off. So that's just kind of you get the stages going. Now let's look at the transition. Now transitions is kind of interesting here. So every time we have like the daily action insert here, that's what that trigger is called, and it's when that current date is being updated from Python. So when for each row, so there's only going to be one row every time it happens, every day, every new day, it'll execute the procedure new day. And so then what new day here does then is it's going to go in, and it's kind of an interesting question. It's part of the extra credit, is that there is some issue here with getting this perfect. It's not perfect as it stands right now. So but what this does is it basically, it's going to go to get all the transitioning, all the ones that transition based on that Markov network, which happens up here. And there's a little bit of trickiness going on here with, basically, the issue is this, is that what is, if you just use random here, so earlier I had just random here, but the problem with that is it does it for all the jobs that are up for candidate for transition. It will only generate one random number for all of them. And so what this does is this basically passes it into this new myRandom function, and it takes as an argument the actual job ID. So now it's actually having random variables for each of the jobs, right? Each of the jobs is getting a random value. The problem is, of course, is that there's two random. If it's the way the join works here is that if there are two arcs of transition, then it's going to get two random variables for the given state. Okay, and what that means right here is what we're doing. We're doing this aggregation here, so that if it happens to be two states, if two random variables, and they both trigger the next action, which happens under the let's see here. So this right here, this reject here, if only one comes back, if only one makes it through, then this reject is not inserted. But if reject gets inserted here, then what happens when we come back to here is that if reject is in there, then we just assume that there was no transition. Okay, so that is definitely skewing the probability coming off of Markov. So I mean, I think writing some more code here and like thinking through a good design, I have some ideas, and but I think it's definitely doable. But that's part of the extra credit. So there's 20 points of extra credit if you can make it a perfect Markov. Okay, so let's just go back here. So daily insert action did that. Now, if we look right here, now we get into the scheduling. So the way scheduling works in this, I'm not really sure if this is perfect either quite yet, but that's something that's good enough to get some tests, is that what it does is that every new job that enters into the working phase, that it works, that is painting, or let's see, we can see right here, if it's either roofing or painting as the stage, okay, then what it's going to do then is it's going to look for a roofer or it's going to look for a painter. Okay, so it's going to want to assign them, and it's going to do this for three. It's going to assign three. If it's a roofing job, it's going to assign 3 roofers for 3 days, right? And that's exactly what's going on here. So it's inserting these into the working order, and of course the assignment dates are the first date available, and that's the finalist earliest available here. So it's actually kind of an interesting algorithm. I think that probably ultimately the way one would want to do this is to figure out the dynamic programming, like some type of knapsack problem. So there are variants of scheduling which are polynomial, and I think we could probably get one of those encoded. So it'd be kind of interesting. I'm not really sure how realistic this is for 3 workers for three days, but anyways, 3 workers for 3 days, so that's like nine assignments. Okay, let's see what else do we have here. Okay, so that's the scheduling work thing. And then here's the final thing, and that is that if you happen to transition out of the stage of a work order while work is still going on, we want to block that because that would kind of ruin the whole meaning. So this is just basically blocking one of the transitions kind of based on the fact that the work has to complete. So we can't have any work orders that are still under this kind of time frame. Okay, so that I hope makes sense. And then what we have here is the final thing here is that we want to switch it as when it's done. What we want to do is we want to insert the done date, so the actual date of termination of the job. We want to insert that at the end of the as it transitions to done. Okay, so when it transitions to done, we want to put that date on there. All right. So I hope that that was kind of And then this one here, yeah, it says finish up here. It's like this. That's what these are doing. Okay, so that's all that there is to it actually in terms of the active server side SQL to get this achieved. Okay, let's just show it then. All right. So this go here, what this does is it just drops it kills the database, and then it builds a new one, and then it basically initializes it, and then it loads in this active server-side code, and then it runs the simulation. Okay, so if I run this, so here we go. So now you see all these prospects that are kind of filing, and so it's kind of going through the days. It's going to go up to like I think March 20th or something, 2024. So it's going to bring all those in. And then what we'll do is we'll just kind of like poke around here just to kind of do a sanity check on what data got represented once we're done here. Okay, so after running that simulation, let's just go and just take a look at the database state here. So of course we have the data, the tables there. So let's look at the jobs. I mean there should be a fairly large number of jobs here. So select star from job. And these ones are all, these are like, there's a whole bunch that want being lost, but basically let's just order it by start date. Order by start. Okay, so now if we look at this right here, so all the ones that we're starting on like January 1st are there, and then we're going, we can't climb through these. So these older ones, they're mostly kind of either lost or done. So they've got their work done. But as we kind of go through time here, this one's still an active painting job. And what do we got here? We got some active roofing jobs. We might see some stuff. There's one in dispute. A painting job in dispute. And it goes on and on here. So then we lost, a lot of loss there. So this is going all the way through. Okay, then we're not even done with January. So there's a lot of jobs actually that came in. If we get, the closer we get though to like March, I think here, we'll see that most of them are in kind of some more of initial states. Okay, so yeah, a lot of these are actually active jobs going on. Okay, but anyways, you get the sense that, yeah, it looks like the simulation definitely started a lot of jobs here. Okay, so I mean, if we just go all the way to the end here, how many jobs did finally, looks like we have over, like how many jobs we've got? Yeah, okay, we have 1,181 jobs. Although it's interesting that there's, okay, so there's those, okay, 1,181 jobs. Okay, so now each of those jobs, of course, the ones that were successful are the one that the ones that were just immediate lost, have work orders, work order associated with them. Oops, work, not word, work order. Select star from work order. Yeah, so these are just like assignments like on the days. Now, it's kind of interesting thing if you look at this. Because of the number of workers we had, we actually we should have had more workers because you'll see what happens here. Let's see here, if I just do this by select star from worker, order, work order by day descending. Okay, look, I mean, we were forced to schedule stuff all the way out into August because we didn't have enough workers. So I think what I should probably do is go back to the simulator and like make it so that we actually maybe we have 100 workers or something. Maybe then it'll be I can try that out later. I think maybe if you put it, you're not set to 100 workers, you won't have that kind of backing up of the work orders. Okay, so let's see here now. Yeah, so all right, so that's kind of that's kind of the state of it. There's not so much more to say now, but you can kind of poke around in here. You can kind of see what's going on with things. All right, now what I'm going to do is I'm going to get to the questions that you guys have to get. You have to get working by Friday on the recitation. Okay, so I'll do that now. Okay, guys, let's look at the problems that you're going to have to do for recitation here. Okay, so I want the SQL that gives us like the work orders for the painters in the first 15 days of February. So this should be kind of like a user-friendly printout. So imagine that people were like painters were being handed this. So it would be like the name of the painter, their name, the ID of the job, and the name of the customer that they're doing the job for. And also, yeah, I'll add this later. Also, the type, is it a roofing or a painting type of job? Okay, yeah. So that, I mean, this is just kind of like make it pretty so that it it kind of comes out. We can see the work assignments. Okay, then. The second one is to extend the table for job to include a column for the sales rep. And I definitely don't want you guys to touch the Python code. So the Python code should kind of stay stable, and you should only be doing your work under the active, the PLPG SQL code. Just randomly assign a sales rep to each the job. Each job as it's coming in at insertion time. Okay, so now in relational algebra, we want to think about those things. We're talking about the inclusion dependencies. So we want to just write down an inclusion dependency in relational algebra that would that basically says that, well, the jobs of a certain type may only be allowed in the permissible stages. If you look at the database, there's kind of like a stages table which says kind of what are the stages of a given job type, and this would would block things like the following. That is, if you had a job that was type roofing and you tried to set the stage as painting. Painting is not a stage in a roofing type job, so that should be blocked. And then the question is that what is the simplest way to enforce this in SQL? Okay. Now we're going to move over here. Problems 4 through 7 are these kind of warehousing questions. So I want you guys to kind of consider this fact table of amount and count. So these are the numeric ones. These are the ones you're going to sum over. And there's already been a little bit of confusion about what count is. Count is almost always 1, because this is this is kind of very much at the granular stage here of like, okay, on a particular start date. I mean, I suppose it's possible the count would be 2 if because it's possible, it's very rare that 2 customers, the same customer, start on the same day. They're going to start on the same stage. They launch 2 painting jobs separately. The duration here, what that is, duration is the. Here, 1 second here. I have to. The duration is the number of days. The duration will be null unless it's a job that's completed, a job that's done, and then it'll be the number of days from the start to the finish. Sales rep here. Okay. So, anyways, this will always be 1, right? But what's nice is that this is this allows the fact that every entry in this is a tuple means that although in principle it's very sparse, actually in truth there's no sparsity to it. And then what you'll wind up doing here is you're going to wind up in the questions you're going to wind up rolling up on some of these. So you'll always get counts that are going to be much more than 1 because it's going to be doing the summing. All right. So do this problem so do it as a view here, just like a straight view. And then use the view here to materialize it using insert into. So in this case, you're going to have a table that's going to materialize the view, and 5 should perform better, much better than 4. But we just want to see what the performance is like. Finally, what we can do here is we can use the group by cube to do something similar, and automatically compute all the crosstabs for count and amount using the group by cube. So I'll go over that tomorrow in class, the group by cube, but it's quite handy. All right, now give the total amount of cash. Okay, here's the question I want you to ask. There's probably better questions, but give the total amount of cash per stage of painting jobs, and then evaluate this over all these 3 different approaches. Okay, now for problems 8 through 10, we haven't gone over temporal databases yet, but there's this concept, and I'll cover it tomorrow, of bitemporality, where you're actually having transaction. Not only do you have the valid time of like the way schedules are happening and stuff like that, we also have the times at which the transactions are transaction start time and transaction end time. So this allows us to recover all previous states on a day-by-day basis of the database. So then, what's the SQL if you think about this number 8 here, give me SQL that returns the jobs that went into dispute but were then ended in a done stage. Notice, because the database as it stands now is a snapshot database, this information is cloaked from you. It's hidden. It's in a prior state of the database. But when we look at a temporal database, bitemporality, we can actually get this solved. So it's kind of a power of bitemporality that we could actually get this answer. We get an answer to this question. what is the average number? And this is kind of interesting. And what is the average number of days a worker was given notice before work on a job commenced? And in this case here, because we didn't have enough workers, it got pretty long. In fact, so people in March were being told booked for August jobs. So that should show up in this. And again, this is the kind of thing that temporal database can help support. All right, and then finally, number 10, try your best. It's not an easy task. It's actually quite hard. It's kind of tricky. But try your best to actually implement bitemporality in the triggers of the defined code. See if you can actually put in the proper conditions to basically make the kind of append-only bitemporal database. Build that up. Finally, number 11, extra credit here. I think I said it already. The random variable is skew. We got to go in and we got to fix it. We got to make it so that there was a little bit of trickiness there that I did, which is not good. We need to kind of make it so that it truly is Markov. Okay. Alrighty. Yeah. So I hope this is interesting, and recitations are very informal, so don't be give it a try. Try all this stuff, and then we'll And again, remember with recitation, even if you try hard but you don't make it or there's a lot of problems, it generates a lot of interesting discussion. So, okay, all right, great. Thanks. Bye.